What is a logarithm, or a log? Well, a logarithm is just an alternate way of writing an exponential expression. So for example, in the past we would say that something like a to the exponent n is equal to x. We can rewrite this as a logarithm. We would simply say that log with a base of a of x is equal to n. These two statements are related, right? For any statement like this, you could write this statement over here. So how could I go from a logarithmic statement to an exponential statement if I wanted to go in that direction? Well, there's one trick that I learned in school, and that's called going around the horn. And that's when you start with a, right, your base, and you go around the horn. So a to the exponent n is equal to x, right? A to the n equals x. And that's what you have written here, right? A to the n equals x. And so if you remember this pattern, say a to the n equals x, you can rewrite a logarithm as an exponent. Let's do a few examples just to show you what I mean. So example 1, we'll have log base 3 of 9 is equal to x. And the question here is going to be solve for x. Well, how can I do that? Well, what I'll do first to start is I'll change this to an exponential statement by going around the horn, right? 3 to the x equals 9. So I'll say 3 to the exponent x is equal to 9. Now I can ask myself, what exponent do I have to raise 3 to get 9, right? 3 to the exponent what is equal to 9? Well, the answer is 2, right? Because 3 squared is 9, so x must equal 2. Another way you can figure this out is by changing the bases on both sides to 3. So on the left you have 3 to the x, and on the right, rewrite 9 as a base of 3, so 3 squared. And if 3 to the x equals 3 squared, then x must equal 2. Okay, let's do another example. Let's say we have log base 2 of 8 is equal to x. Okay, same idea. Go around the horn, like that. 2 to the x equals 8. So we're saying, what exponent would I have to raise the number 2 to get 8? Or in other words, let's rewrite both of these bases as a base of 2. So 2 to the x equals 2 to the 3, right? Because 2 to the 3 is 8. Therefore, x must equal 3. Okay, let's do some more. Let's say I have log base 2 of 16 is equal to a. Well, instead of rewriting this whole thing as an exponent, we can just think about what this is asking, right? It's saying 2 to the a is equal to 16. So it's asking us what value of a as an exponent on 2 would you need to have to get 16, right? So what exponent do you have to raise a number 2 to get 16? Well, the answer would be 4, right? Because 2 to the 4 is 16. If I asked you something a little bit different, like log base x of 27 equals 3, well, this is a little bit different now, right? If you go around the horn, you're saying x to the 3 equals 27, right? And now you're saying, what is x equal to? So we have to know what number cubed gives you 27, and the answer is going to be 3, right? Because 3 cubed is 27. 3 times 3 times 3. So that's how you figure that out. So they could put the variable anywhere in the logarithm, right? They could do this as well. They could say log base 5 of c is equal to 2. So what is this saying? Well, this means that 5 to the 2 equals c. So 5 to the 2 equals c. Well, that's pretty straightforward, right? c is just equal to 25, right? Because 5 squared is 25. So they could put the variable at any one of these 3 positions, right, in the logarithm and have you solve for it. And in all cases, it is manageable, right, as you can see here. All right, let's do some more. What if I have log base 10 of 1 is equal to b? Now this is kind of a special one, right? Because if you rewrite this as an exponent, you see that it's 10 to the b equals 1. And now you're left asking yourself, 10 to the exponent what gives you 1? Well, this is kind of a trick question because any number to the exponent of 0 is going to give you 1, right? So b is equal to 0, right? Because any number to the exponent 0 equals 1. So that's kind of a special one, right? You could also say, you know, log base 15 of 1 is equal to 0, right? You could say log base 7,326 of 1 is also equal to 0. Log with any base of 1 is going to equal 0 because any number to the 0 is equal to 1. Okay? Let's look at some other examples. Let's say I have log base 10 of 0 is equal to c. What is c equal to? Well, let's write this as an exponent. So 10 to the c equals 0, right? So what is c? Well, what number would I have to raise 10 to as an exponent to get 0? Well, if you think about it, if you raise 10 to 0, that's 1. If you raise it to a positive number, that's just a positive, right? If you raise it to a negative number, well, it's still positive, it just becomes a fraction. There's no number as an exponent that you can raise the number 10 to get 0, right? So c is going to be undefined. So you never really want to take log of 0 because your answer is going to be undefined, because there's no exponent you can raise a number to get 0, right? Unless your base is already 0, assuming, but we don't have a base of 0 with logarithms. It's usually some number, right? Okay, so let's look at another example. What if I have log base 10 of negative 100 is equal to d? Well, this is saying that 10 to the d is equal to negative 100. What is that, right? How could I solve for d? Well, we know that 10 squared is positive 100, right? But there's really no way you can get 10 to turn into a negative number by raising it to some exponent, right? So again, we're going to have to say that d is undefined. So rarely do you want to take the logarithm of a negative number, right? It doesn't really make sense. So we're going to say that d in this case is undefined. So there's some examples like this one and the last one where what we're asking doesn't really make sense, especially when you start thinking about it as an exponential, right? Which is why it's useful to put it into that exponential form, because then you can see, oh, this statement doesn't make any sense. How can you get a positive to turn into a negative with an exponent, right? Like that's not possible. So let's do some more examples. Let's say I have log base 10 of 1/10 is equal to x, and let's solve for x. So 10 to the x equals a tenth. What's x equal to? Well, you should know, looking at this, that x is equal to negative 1, because when you have a negative exponent, that causes the base to become the inverse of itself, right? It flips upside down, if you want to think of it that way. Okay, let's do another one. If you have log base 3 of 1/9, and that's equal to z, solve for z. So let's rewrite this as an exponent. 3 to the z is equal to 1/9. Now if you want, you can probably take a guess as to what z is going to be, or you can try to rewrite the right side as having a base of 3, right? So however way you want to do this. In my mind though, when I see a 3 and a 9, I know that the z is going to have to be a square, right? It has to be a 2 to turn that 3 into a 9. But it's not just 9, it's 1/9, right? So this has also been flipped. That tells me that the z must equal negative 2, right? Because if you think of what 3 to the negative 2 is, well, 3 to the negative 2 is 1/3 to the 2, which is 1/9, right? So if you think of it this way, it's not too bad. You can get your answer. It's just recognizing what that exponent is if you're given the answer at the start. Okay, so that's how you could check your work also. Now, one rule that's important to keep in mind is you don't want to have a negative base. And when I say base, I'm referring to that little number next to the log. So like log negative a x is equal to n. You don't want this number here to be negative like that, okay? Because if you were to rewrite this as an exponent, you'd get negative a to the n is equal to x, right? Meaning that depending on this n value here, whether it's even or odd, things are going to get messy because your answer is going to switch between positive and negative all the time, right? So this no longer really works like a nice continuous function, because depending on what that n value is, the sign is going to be bouncing all over the place, right? Like if n was 1, this is a negative. If it's 2, this becomes positive. If it's 3, it becomes negative again. And then what happens with all those exponents that are in between 1 and 2, right? Like all the fractional exponents, what happens, right? So this becomes very, very messy. So you want to make sure you don't have a negative base when we're talking about logarithms. Okay, and that's it.